In this video, we will demonstrate the results of a Fusion Broadband Hybrid solution. All the tests in this demonstration are run from the Fusion Client portal. From the login page, we enter in our customer login and passwords. Once logged in, we will proceed to Bonding Admin, then into Bonds. Here we see that we have one bonded profile in the account. We then select Details on the top right to open up the specific bond. Scrolling down the page, we can see there are two legs being bonded. One, a PPP-based ADSL service, the other, a mobile broadband connection. As this is a Fusion hybrid bond, the ADSL service will carry both up and downlink customer traffic. The mobile broadband service will only carry uplink customer traffic. Let's run a speed test on the ADSL service. First, a downlink speed test. All the Fusion speed tests are isolation tests, meaning that the only data on the link while it is being tested is the test data. We can see that we have a speed of around 12.5 megabits per second and a load latency of around 35 milliseconds. Now, an uplink speed test. And the result is 0.88 megabits per second. This is about right for a reasonable ADSL 2+ connection. You will note the very high latency. This is caused from packet queuing on the connection. As this is a flooded test, we are pushing this as hard as we can. Now let's have a look at the uplink speed of the mobile broadband connection. We won't test the downlink speed as the hybrid profile doesn't use it. And here is our result. Excellent speed of just over 21 megabits per second. Again, the latency is quite as high as we would expect. The latency reported here is the latency while the test is running, which is far more important than reporting the latency on an idle or unused connection. Now, wouldn't the ideal scenario be to grab the downlink speed of the ADSL and marry that to the uplink speed of the mobile broadband connection? That's exactly what we are going to do. So let's test the bonded connection with the mobile broadband service put into idle, meaning that no data in any direction will flow over it. First, a downlink test. And here is our result. Note that the downlink speed is now higher than that speed reported on the ADSL downlink test. The reason why is our TCP acceleration process. This ADSL service cannot run over 12.5 megabits per second on a single TCP flow or session, but it can if there are multiple sessions. Our TCP acceleration process turns single flows into multiple flows to get over this restriction. It helps a lot with congested services, cable, and even mobile broadband type connections. Let's now run a test in the uplink direction of the bond. Remember, the mobile broadband connection is in idle, so it is not being used. Here's our speed, 0.84 megabits per second. Note the latency. The bonder is managing the latency and keeping it at a much more usable level, even though the connection is highly loaded. Now we are taking the mobile broadband connection off idle and making it active. This means that it will now carry customer uplink traffic. Let's run a test on the bond. The result is 16.5 megabits per second, just as we expected, as this is just the ADSL service carrying the data. And the latency is pretty good too. Now let's run an uplink test, which will include both the ADSL and the mobile broadband connection. Here is the result. over 21 megabits per second uplink. Note the latency 45 milliseconds, way down from the uplink latency of both the ADSL or mobile broadband services on their own. Let's bring in another speed test tool, speedtest.net. We will pick a test server in Sydney and let the test run. Here is our downlink speed, 16 megabits per second, which is about right given that there may be a little other network traffic flowing on the link as well. And let's see the uplink speed. Right what we expected, at 21 megabits per second. Let's give this a real boost. In the portal, we are going to turn on compression, which will compress any non-encrypted data that is compressible. The speedtest.net download file is compressible, as you will see. Let's test again. Here, you can see the download direction is now running at 33 megabits per second. Uplink is the same, as the speedtest.net file type is non-compressible. Fusion Broadband Hybrid, combining the downlink and uplink speed of ADSL to the uplink speed of a mobile broadband connection, all delivered with a single static public IP address and seamless failover/failback to protect you from connection failures.